Hello and welcome back to another video. We were talking about algebra in the last class, and what I have is a continuation of the lecture. We had learned how to expand brackets. Whatever was outside the bracket got multiplied with everything that was inside the bracket. Now, on the exam, you may have questions that relate to expanding products of algebraic factors. Okay, so for example, when x plus a multiplies with x plus b, you multiply every term in the bracket in the first bracket with every term in the second bracket and so on. Okay, I'm going to do a few examples for you here. For example, in the first one, what's going to happen is x in the first bracket is going to get multiplied with x minus 3 and then plus 2 and then x minus 3 again. Now then after that it's just simply expanding brackets. So x into x gives me x square minus 3x plus 2x, and 2 into minus 3 gives me minus 6. So my final answer is then x square minus x minus. Okay, for the next one then you multiply 3a with 2a plus 5, and you also multiply minus 4 with 2a plus 5. So you get 6a squared minus plus 15a minus 8a plus 20. I'm multiplying like that. So 6a square plus 7a plus 20. X multiplied with x minus 1 plus 1 multiplied by x minus. So I get x squared minus x plus x minus. So in the net, I get x square minus 1. Now, you might remember this typically from a difference of squares that you might have studied, which was this a plus b into a minus b. This expands to a square minus b square. That's something that you could rote learn, but here we are expanding algebraic fractions, algebraic factors. So what I'm going to do is I'm going to do it the long way and say that a into a minus b plus b into a minus b. So I get a square minus ab plus ab minus b square. This cancels out and I get a square minus b. Okay. Two into 5 plus s minus s 5 plus s. So 10 plus 2s minus 5s minus s. That gives me 10 minus 3s minus s. Then I could have higher powers as well. So x square could multiply with x plus 2 plus 1 and then x plus 2. So I get x cubed plus 2x square plus x plus 2. Okay, I can't add any terms now because they're not like terms. Let's move on. Now I could have a product of 3 terms as well, which is absolutely fine. It's going to work in the same way. A square, okay, then ab minus a. Then I could write ba or I could write ab again. Then that's b square and minus b. Okay, nothing cancels out in this case, so I'm going to have a square plus 2ab minus a plus b square minus. Now this is a little tricky. H. Now a lot of people get confused when they're multiplying this together. The simple idea is you separate this and say that there's a bigger bracket here, So you first multiply within the bigger bracket and say that this becomes 2x square plus 3x. And then those terms get multiplied with x plus 4. So 2x square into x plus 4 and plus 6x. Sorry, my bad, 6x. 6x into x plus 4. So I get 2x cubed plus 8x square plus 6x square plus 24x. 2x cubed plus 14x square plus 24x. I do this for the next question as well. I'd first multiply these two brackets and then multiply it with the third one. I could choose to multiply the other two first as well. It's up to me. But I'm going to put a bigger bracket here before I start multiplying. And there's a smaller bracket here. X square plus 5x minus x minus 5 to x minus 3. X square plus 4x minus 5. Then you multiply x square with x minus 3 plus 4x with x minus 3 and minus 5 with x minus x cube minus 3x square plus 4x square minus 12x minus 5x plus 50. X cube plus x square minus 17x plus 50. Okay, so slightly long problem, but that's how you would solve it. There's a practice exercise for you to do if you are not sure about some of the questions that were done above. The easy part of learning math is to do practice. Okay, so there are about 26 questions on the screen. You could take a screenshot and start practicing. Okay, what I'm going to show you next is algebraic identities. Okay, what are algebraic identities? Now, you must have seen these in your early grades, that you were made to learn a square plus 2ab plus b square. And this became a minus b whole square, became a square minus 2ab plus b. Okay, now while I see the advantage of learning these identities, I often see a lot of people making mistakes. It says be careful with an expression like x minus 3 square whole square. It is not x square minus 9. Remember that. Why? Because x minus 3 whole square is basically x minus 3 into x minus 3. And then when you multiply it in the normal way that we just did, you end up with x square minus 6x minus plus 9. Now, even when students sort of remember this, the mistake that they tend to make is that they often mess up the signs. Okay, so I've seen a lot of students do this, that they say that this x minus 3 whole square should be here, and then what they end up doing is write this instead. Okay, remember that if you are remembering two identities, a plus b square and a minus b square separately, then what you need to ignore is the fact that there's a sign in the middle. Why? Because that you've already integrated that into your formula. Okay, you could apply this to this first identity and say that this is x squared and then there's a plus outside, and then it works fine. So if you remember two identities, forget the sign. If you remember just one identity, that's the one on the top, then you need to remember then you need to plug in the signs as well. Okay, so this is something that you need to remember, comes in very handy when you're doing fact, this is the end for this video, and I will see you with another video in the next recording. Thank you for watching.